In this video, we're going to talk about how we can use tools such as John the Ripper in order to crack passwords on Linux. Now, passwords on Linux work a little bit differently than how passwords under Windows work, and it turns out there's a lot of history behind how they work because of the fact that Linux has been around for quite so long. So let's go ahead and get started, jump into that. First thing, here's our network diagram. We are going to be jumping down here, or starting off down here on this external machine right here. That's a Linux machine. That's a Kali or backtrack machine. We're going to be looking at the passwords that are on the current local machine. Eventually, we will be coming up here to the internal backtrack machine, and we'll be logging in first off via legitimate methods from the internal machine to the external, and then via illegitimate methods to show that once we've started working with passwords, some of the tricks that we can use to get around them. So let's look at it. So first off, we start off on our Linux machine. And pretty much everything under Linux works as a file. The first file we're probably going to be interested in is the cat. Is to be able to cat. First off, cat is simply print out a file. But the file we're looking for is etc password. So cat /etc/passwd. When we hit this, it prints it on out. And so we can go ahead and we can scroll on up in here and we will see, we start off with root. And then we've got some X here, a 0, a 0, root again, /root, and then bin bash. Very briefly, what we're looking at here is, first off, the username is root. That is the name that we would use to log in. The X normally is where the password would be stored. The 0 and 0 is the user ID and the group ID. So in this case, root is user 0 as well as group 0. Let's see, this root, I'm going to admit I'm a little rusty on it. I'm not exactly sure what that root is for, but this /root is where its home directory is, and then the /bin bash is its login shell. So we can look through here and we can see other people such as news, user ID 9, group ID 9, their login directories in the var spool news with a bin sh path. So we keep looking here. Probably this guy right here, syslog. It does have a home folder, home syslog, but its login is /bin/false, which means you can't actually log in with that. Same thing with the next one, user sbin no login. So you can't log in as the SSHD user. But if we go down all the way to the end, we'll see this guy right here, Haxor, which is our hacker account. You'll notice that the user ID and group ID jumped from 113 to 1001. And then the home /Haxor and the bin /sh. Well, now that's the password file. And you may be thinking it's kind of missing a passwords. Well, the passwords originally were in there, and that's where this X is, in between the two colons there. But there are reasons why this password file needs to be readable by everybody. Basically, what happens is when this Haxor user logs in, he looks at this file and he says, where's my home directory? What should I be setting that to? Where's my shell? What should I be setting that to? So it actually needed read access to this file. We can confirm this if we do an ls-l/etc password. Oh, that's nice. ls-l/etc/password. And then over here on the left-hand side, we can see the permissions. This first dot first dash has to deal with the file type. In this case, it's blank, which means it's a normal file. The first 3 spaces have to do with the user permissions. In this case, the user is root, as we see right here, and therefore the root user has read and write. The next 3 locations have to do with group. In this case, it is just R. So the group, and again, the group is root, only has read access. And then the last 3 is for everybody else. And again, everybody else only has read access. So everybody on this computer has access to the etc password file. Now, obviously, if we're storing passwords in there, that's not good. Even if they're encrypted to some degree, it still allows a malicious user to be able to look at and possibly copy other people's accounts. Because that was so questionable, what happened was Linux people came around and they said, you know what, let's stop using the password file. Instead, let's use the etc shadow file. This is called the shadow password file. And at first glance, it looks pretty much similar. We've got the root user. This time, however, we've got some, between the colons here, we've got a hashed password. Oh, that's kind of nice. Some of these guys have X's in there, which means that they don't actually have passwords either. So the sync user doesn't actually have a password. And then we go all the way down to the end here, and we will see the Haxor user with a hashed version of the Haxor password. Great. Hey, that's kind of handy. If we then look at the permissions, of the etc shadow, we will notice that the root user has read-write permissions, and then the shadow group has only read permissions. So it restricts who has access to actually look at the passwords. That's kind of elegant. All right, well, let's create some users in here in order to start working with them, to try to hack these users. So we'll start off with the command user add Yoda. I'm going to create a user. If we, let's see, while we're here, let's also user add Chewbacca. Now we can go ahead and we can look at the etc password file. I'm going to do a tail/etc password. Tail is similar to cat, but only shows the last so many lines. So we see here was our Haxor user. Again, user ID 1001, group ID 1001. We then created Yoda, user ID 1002, and then Chewbacca 1003. That's the way it normally works when you're creating these users. It simply adds them to the bottom of the list and increments the user and password ID. If we then also look at the etc shadow file, so tail/etc shadow, we see the same thing. Again, there was the Haxor user with his hashed password, and then we see Yoda with an exclamation mark and Chewbacca with an exclamation mark where the hashed passwords normally are. That means those passwords don't yet exist. All right, well, while we're here, let's look to see what other type of information we might be able to find on this system. On a Linux machine, there's also a file, a log file in the var log auth log file that keeps track of changes to authorization aspects of the computer. For instance, we could see in here, hey, right there, we created both a user and a group called Yoda. And a few seconds later, we created another user and a group called Chewbacca. So it does actually log all of this for us if we work through in that option or in that method. If I'm a system admin and I'm curious about security for my environment, that is definitely something I would be watching for new user and new group commands. All right, so that was setting up the creating some new users. Those users currently don't have passwords, so let's set some passwords for those. To create a password, we use the password command, passwd, and then the user we're going to set the password for In this case, we're going to do something really simple. We're just going to do green for both Yoda and for Chewbacca. Very simple passwords because we're less concerned about security at this point. We're more concerned with the processes around how we might possibly break those passwords. Very briefly, let's do a tail -n2 of the Etsy shadow. Basically, what I want to do is I want to look at the last 2 lines of the shadow file. The last 2 lines are Yoda and Chewbacca. And we'll see Yoda now has a password hash, and Chewbacca now has a password hash. You'll also notice those passwords aren't the same. Well, there's actually a reason for that. This is what's called a salted hash. Basically, it's a way to make sure that if 2 people have the same password, that their hashes are not the same. Additionally, we can then look in our var log auth log, so tail var log auth log, and we can see in here, maybe? Looking for, oh, there we go. Password changed for Chewbacca. So again, if I'm a security admin, that might be something I would want to look for and alert on so that I can then quickly see if people are working in machines, specifically with user accounts that they shouldn't be changing. More specifically, if I wanted just to look for password change, I could look through the whole var log auth log, and I could specifically look for the keyword changed. And I'll see all the users who had their passwords changed at one point or another. All right, so that was kind of the setup. Let's start breaking in. In this case, we're going to be using the tool John the Ripper. Now, John the Ripper is already on here in these pen test passwords John folder. And if I do a ./John and hit enter, it gives me all the details about how to use John the Ripper. All the switches, all the command line options. For the most part, however, I can just run John and a password file. Let's try that. So I'm going to do John again, so ./John, and then I'm going to point it to the Etsy shadow file. So I'm telling it, go ahead and look at the shadow file on the local machine and try to break these passwords. And this is going to be doing what's called a brute force attack. Basically, it starts off with the letter A, and then tries the letter B, and then the letter C, and so on until it pretty much finds all the passwords that are on the machine. This may take, I don't know, about half a minute or so to run because we have such simple passwords. I'd already found the first one, root's password of tour. There we go, found Chewbacca and Yoda very quickly, and then found the Haxor password of hacker. So it found 4 different passwords, it says. Even though both of these guys had the same account or the same password, they also had different salts, and therefore they had to be tested separately. Total of 39 seconds. Not too shabby. Now, if I was to try that again, if I just simply up arrow and try to run that again, it's going to say, yeah, there's nothing left. There's no passwords left to no password hashes left to crack. And this is actually a benefit of John the Ripper. John the Ripper is smart enough to know you may not be able to get everything in one pass. So it actually created a file that keeps track of where you are so that you can then pick up where you left off. And that file is john.pot. And here we see in john.pot, here is a hash. And here's the corresponding password of TOOR. Here's another hash. And here's the corresponding password. And so it's already hashed all or captured all of those passwords. And therefore, when I try to rerun it again, there's nothing in there. Okay. I could delete this file. So I could just simply echo a blank line into john.pot. And then now rerun John, and it will continue to rehash those passwords. So if I needed to, I could reattack the system. I don't really want to wait 40 seconds, so I'm going to actually hit Control-C. I'm going to cancel that, and I'm going to delete that john.pot one more time. Now, that was using a brute force attack. I could also use a password list. And it just so happens there is a password list here on this folder called passwords.lst. Right there, passwords.lst. And if I, let's see, head -n20 passwords. There we go, password.lst. It tells me, well, so it starts off with some comments. It says, yeah, this was updated in 2011, so it's kind of old. At which point there are 3,546 entries. It starts off with 1, 2, 3, 4, 5, 6. Okay. Well, that's how it starts. Let's change some of our users so that we can start using that. I like this computer password. I'm going to change Chewbacca's password to computer, just so I can use this password list just to see how it works. So password Chewbacca. When it comes up and asks me, I'm going to type in computer. All right. Now let's go ahead and use John the Ripper. So /John/SC shadow. And this time I'm going to do a -- word list equals password.lst. So this is pointing it to the word list that we just looked at, and we can see, yeah, very quickly it found Chewbacca's password. It also found Yoda's password pretty quickly, and Hacksaws, and I believe the last one, will Tour show up? We'll find out. No, it only found 3 of the passwords. All right, well, let's look at that password one more time. Let's try tail password.lst. Tail shows the end of the file, head shows the top of the file, and here we can see here's all of these guys. All of these were the final 10 passwords. I like this new court password. Let's go and change Chewbacca's password to new court. So password Chewbacca. And we'll go ahead and set it to new court. New court. There we go. Up arrow a couple more times. Get back to our John command to using the etsy shadow with the password list. And now it should continue on and hopefully find our new password for Chewbacca. There we go. It found Chewbacca with the password of new court. Hey, password lists are great. You will notice that took significantly longer because it was at the end of the password list. Yeah. All right. So that's been attacking the local machine. Let's look at the possibility of what would it look like if we were attacking from a remote machine. Now that Etsy shadow file is extremely handy because it's just a text file, and I can copy that from a remote machine to this computer. In fact, I've already done that. I have a file in my root home directory. I have 8 called shadow. And here I can see this is the shadow format. I've got some users I've got, for instance, administrator with a hashed password. I've got Bart, Lisa, Cartman, Stan, and Big Bird all with different hashed passwords. Let's go ahead and run John the Ripper on it. In fact, let's just try the brute force. So /John, and then point it to that file. So root lab 8 shadow. It says it found 7 different passwords. Well, that's really easy. Administrator's password is password. Root's password is password. Big Bird's password is yellow. Wow, that's just crazy. It's going to keep searching and it's going to find the remaining users. All right, well, while that's going, let's start transitioning into the next topic. The next topic is going to be talking about using passwordless login and how we can hide a new account under Linux. We were seeing through those log files there as we were creating new users and as we were changing their passwords that the logs were showing that the users were created. Turns out there's a couple of things we can do that will stop that from being evident. I'm actually going to open up a new terminal here. Let's see, File, New Tab, because I want this task to keep running. But what I'm going to do is I'm going to use a command called gedit, and I want to edit the etc password file. Gedit, it's a GNOME editor, it's a graphical editor. Now, what we've been doing is when we've been looking at this etc password file, we've been noticing that users are created down here at the bottom, which is very, very obvious to any security admin who's even briefly looking at the system. If there's somebody new at the bottom that you don't know about, that's going to raise some flags. Well, what if we put somebody up above at the top? In fact, what if we took this root line and I copied that and then hit enter and then I pasted the line in right there. Now we can go ahead and edit this, and instead of root, let's call this user Vader and then save it. Now, if we think about some of the stuff that we've already learned about how this password file works, the first name is the login name, root or Vader. This X is where the password would have been. The user ID is 0, the same as the root's user ID, which means all permissions given to user 0 will also be given to user root. To user Vader. Group ID is also 0, the same as root. Still has login permissions as root. The home directory is root, and then still going to be using bin bash. Essentially what we're doing here is we're creating another user, and we're saying this guy is pretty much root. This is the twin of root. That's kind of interesting. All right, well, let's go ahead and save that and close it. And then I'm going to run gedit one more time, and instead of etc password, I'm going to do etc shadow. And this time I'm going to do the same thing. I'm going to copy the root user, and I'm going to paste him in, and instead of root, I'm going to change that to Vader. Now that appears on 2 lines simply because the text editor is wrapping the text around, but it is actually 1 line altogether. So here we are, we're creating a Vader user that is cloned from root and has exactly the same password. So different user, same user ID, different, or currently the same password, but eventually I could change it. All right, let's go ahead and save that and close it. And now, before, when we were creating users, we were actually able to find histories of those users being created. If I look in the var log auth log, this time I won't find any reference to the user Vader being created. In fact, I could even look through that whole file, cat var log auth log, and grep for the name Vader. And he doesn't show up at all. I just created a user, and there's no record of that user ever being created. Most security admins, when they're doing general maintenance on the system, they may come in here and they may tail the etc password file to see which users have been created recently. And they'll look in here and they'll say, oh yeah, I remember creating Chewbacca a couple weeks ago. And then assume everything is perfectly fine. However, we put Vader up at the top of the file. And since they only come in here and they look at the end, they're not going to notice him. Not unless they do a head instead of a tail. Would they find Vader? All right, well, hey, let's try to log in as Vader. Let's try to set some some stuff up so that we can log in from other machines. First thing I'm going to do is I'm actually going to run. Let's see. First off, let me get back to the home directory, to my home directory. Just going to cd takes me back to my home directory. I'm going to run the command sshd-generate. And then hit enter a couple of times. Oh, didn't need to hit enter. All right. sshd-generate, what it does is it sets up some keys. Keys? Well, keys work very similar to how keys in your house would work. The keys let you in the house. If you have the key, you can get in. All right. Now that I've set up the keys for the server, let's go ahead and start the server. So /etc init.d ssh start. Yeah. Okay. I can actually confirm that that's working. netstat-tan grep 22. Since SSH runs on port 22, I can see, yes, TCP port 22 is listening. Awesome. All right, let's go ahead and log in from a remote computer. I'm going to be logging in from a Windows 7 machine. There we go. I've got PuTTY right here. Gonna go ahead and launch that, and then for the IP address 216.1.100 and open. Very first time you log in with SSH to any host, it says, hey, who are you? I'm sorry, hey, do you trust this machine? Yes, I trust it. Who do I want to log in as? I want to log in as Vader. I want to make sure Vader works, and Vader's password is TOOR, the same as root's password. Hey, that's kind of nice. So I created a user and I logged in as that user. Now, remember when we were looking at permissions before, ls-l /etc shadow, I can see the root user is the only one who has access to this. But remember, computers don't really remember who users are. Computers remember user IDs. Since Vader has the same user ID as root, we're not really saying root has access to this machine. We're saying user ID 0 has access to this file. Well, Vader also has user ID 0. So that means Vader should have access to that file, even though it doesn't say that he does. Well, let's find out. Head etc shadow, not heat. Head etc shadow. And yes, I can view the contents of that file. I do, in fact, have access to that file, even though I'm currently logged in as Vader. Now at this point, I am actually leaving some logs behind. I am leaving some trails behind in my auth log. So if I did a tail var log auth log, I do see right here the user Vader logged in. So I do actually, and because I'm logging in as Vader, I am leaving some logs saying that this user exists and is logging into the machine. Well, okay. Let's take a different look at this. Let's see if we can do some passwordless logins. Now for that, I'm going to log into another machine, another Linux machine, which is this guy right here. If I looked at my network diagram, this, see, my external machine had the white background, and then my internal machine has a black background. Why the difference? Just so I can tell the difference between which machine I'm on. So from the internal machine, I want to log into the external machine, and I want to prepare this to be used with passwordless logins. So here on the internal machine, I'm going to use Ssh Keygen in order to generate the public-private keys. So I ran that command. Every time it prompted me for something, I just hit enter. Not a problem. There may be reasons why you would want to have different passwords or different settings in there, but that's what I'm working with right now. So that public-private key, basically there's a private key that I keep, and then there's a public key that I can set off to a remote machine. Once the remote machine has that public key, I can then log in and then use those keys to verify who I am. So I've created the key. Now let's send the public key out to our external machine. For that, I'm going to use SCP. SCP stands for Secure Copy. Secure Copy, I'm going to copy from the .sh/id_rsa.pub file. So this was right here is where we created the file, was in the .ssh folder with the ID RSA pub. This guy right here. That's the public key. Where do I want to send that? Well, I want to send it out to my external machine. So I want to log in as Vader at 216.6.1.100. And I want to copy that to the root.ssh authorized keys file. Now again, this is the first time this computer has logged into that computer. And it says, are you sure you want to trust this? Yes. Very first time it prompts me for root's password, or more specifically Vader's password. So I have to type that in. And it says, okay, I went ahead and I copied that. Great. Okay, so it logged me, it copied the file and then logged out. Now I should be able to SSH straight into that machine, 216.6.1.100, and it will log me in without a password. Isn't that great? The keys allow me to log in without a password. Oh, that's kind of nice. So I exit, and then I log back in, and I'm back in without any concerns. Okay. Well, what if root changes his password? I mean, we've gone through a lot of setup here. What happens if root comes along and just changes his password? Well, let's go find out. Let's go back to our external machine. Currently logged in as root. Let's go ahead and change my password. Password root. Let's go ahead and change it to 123. Really silly password to use, 123, but it's sufficient for what we're looking for. Now that I've changed root's password, let's go ahead and let's go back to the internal machine. And again, let's try to SSH in. Remember, Vader had the same password as root, but we set up the keys. So now I log in and the keys take me right in. It doesn't even ask me for passwords. Oh, that's nice. About the only way that that my target machine can keep me out is if they come in here and they're like, hey, I think somebody's logging to my machine. Let me look at the .ssh, oops, not ls, cat, the .ssh/authorized keys file. And they may see in here, you know what, I'm seeing this root at BT. I don't know who that is. Hopefully it has a different name to tell us. So I'm going to actually just delete that. I'm going to rm-rf root. Oh man, that's a horrible command. Don't do that. Echo greater than .ssh/authorized keys. There we go. So I just wiped out that file. No longer any keys in there. Now, if I go back to my internal machine, I'm sorry, to my internal machine, and now I try to SSH in. Now it starts prompting me for the password again. All right, so that was a lot to cover. We talked about using John the Ripper in order to start hacking Linux passwords, and specifically the different types of files that there are that hold passwords in Linux machines. We then talked a little bit about our authorized keys and how we could use those in order to permit passwordless logins. And then we also talked about how we could circumvent some of the standard monitoring tools in order to create accounts on these systems that won't be quite as obvious to the unsuspecting security admin.